In this video, I'm going to introduce a table of values from the standard normal cumulative distribution function and work through some problems with the normal distribution. The standard normal cumulative distribution function is illustrated in the figure on the top left. The x-axis in this figure are values of z, our standard normal deviates, and on the y-axis is the probability of being less than or equal to z. In the table below, you can see I also have values of z. These are the values that are on the x-axis in the figure. And I also have values for the probability of being less than or equal to z, which are the values on the y-axis. To use the table, I typically go to the portion of the table that has a particular value of z, and then I look at the probability, or I start with the probability and find z. In the examples that follow, we'll do it both ways. We'll also see how we can go from a standard normal distribution to any other normal distribution through a simple transformation of the results. The first problem asks, in a standard normal distribution, what proportion of cases lie below 0.95? The best way to get started with these problems is to draw a picture of what you're looking for. I can draw a standard normal density function that's going to have a mean of 0. And what I'm looking for in this problem are the proportion of cases that lie below 0.95. 0.95 is located probably about right here. And what I'm interested in is this area under the curve, which corresponds to a value in my standard normal CDF. What I'm looking for then is the probability that z is less than or equal to 0.95. And I can find this by going to the right place in my standard normal CDF table. I'm going to find the value of z of 0.95, and if I look at my table I can see that it's here. And the corresponding probability that the value is less than or equal to this number is 0.8289. And that's the answer, 0.8289. The second problem asks, in a standard normal distribution, what proportion of cases lie above negative 1.03? Again, I'll start with a picture. And I'm looking for values that are above negative 1.03. And what I need is the area under the curve above negative 1.03. So the probability that z is greater than or equal to negative 1.03, that's actually going to equal 1 minus the probability that z is less than or equal to negative 1.03. And so I'm going to have 1 minus, and I need to go into the table to find this part. So I need to find the probability that z is less than or equal to negative 1.03. Here is my value of z. There's the corresponding probability. And I need 1 minus that, so I'm going to say 1 minus 0.1515, and that's going to equal 0.8485. So the probability that z is greater than or equal to negative 1.03 is 0.8485. This next problem is a little more complicated. It states, in a normal distribution with a mean of 45 and a standard deviation of 6, what proportion of cases lie below 41.58? I'll start by drawing it out. And so in this distribution we have a mean of 45, and I want to know the proportion of cases that are below 41.58. And so I want this area under the curve. Since the normal distribution of interest has a mean of 45 and a standard deviation of 6, but my table is for a normal distribution with a mean of 0 and a standard deviation of 1, I need to start this problem by computing a z-score. In this case, I'm going to have z equals 41.58 minus the mean, which is 45, divided by the standard deviation, which is 6. And that's going to be negative 0.57. So now what I need to find is the probability that z is less than or equal to negative 0.57. And so I go to my table and find that value of z. Here I have negative 0.57, and the corresponding probability is 0.2843. And so for a normal distribution with a mean of 45 and a standard deviation of 6, about 28.43% of cases lie below 41.58. This problem asks, what is the 70th percentile of a normal distribution with a mean of 100 and a standard deviation of 16? This problem is different from the others because instead of having a value for which I'm trying to find the probability, I'm given the probability and I have to find the value. And I can do this by going to our table again, but what I need to find is the value of z, where the probability is 0.70. And so if I go to my table, I need to go to the column labeled the probability that z is less than or equal to some value and find 0.70. Now you can see in this table I can get pretty close to that. The table does not give me values that are exactly 0.7. I could use linear interpolation and find the value that I need in this table, but a simpler option is to simply go to the value that's as close to 0.7 without going over. And this works because I'm using percentiles. So I want the value that's as close to 0.7 without going over, and that's going to be 0.6985. And so the value of z that I want is 0.52. All right, so z is going to equal to 0.52. But this value of z is for a standard normal distribution. I now need to find the value from a normal distribution with a mean of 100 and a standard deviation of 16. And I can do that by plugging these values into my z-score equation. So z is 0.52, and that's going to equal to x, the value that I want, minus the mean, which is 100, and that quantity divided by a standard deviation of 16. And with a little algebra, I get 0.52 times 16 plus 100 equals x. And that's going to be 8.32 plus 100. And that's actually going to equal 108.32. So the 70th percentile of a normal distribution with a mean of 100 and a standard deviation of 16 is 108.32.